So this class is going to be about soils. I didn't realize how interesting soils were until I went to college and took my first soil class. The university made me take it for my major in environmental science. I thought it was going to be the lamest, dumbest class ever until my first day when the professor showed us some really shocking things. One of the first things he did was he got a front end loader and dug a deep hole in a field just to show us pictures of how complex our soils really are. The other thing he led with was a concept like this. From world history, you know this area as the Fertile Crescent. This is the birthplace of most civilizations in the world. This is where a lot of languages began, and this is one of the first places where people attempted agriculture. If you go to this region today, it is no longer the Fertile Crescent. The first places where we did large-scale agriculture, we destroyed the soil and created this mess. So, and another thing is, we often talk about what are humans going to run out of on Earth first. It's not going to be fossil fuels. It's not going to be air. It's not going to be water. What it actually is the limiting factor is how much soil we have to grow food. The fancy term for soil good enough to grow food is called arable land. So if you imagine an apple represents the Earth, the size of that sticker on the apple is how much soil we actually have to grow food. The size, including the volume of that sticker. So arable land is the soil that we need to grow food. As you can see in the US, we're doing relatively well. One reason why we're green is they're averaging the entire country. A lot of regions are too cold or too dry for growing food. So there's a lot of things that prevent us from growing food, as well as cities spreading or urban sprawl are also reducing the amount of soil that we have to grow food. So you got to factor in places covered with water, places that are frozen, remove dry areas, high mountain areas, as well as areas where there's just not much soil. And that's also why you can't call it dirt. Dirt is dead. Soil is composed of a few things. It's weathered parent material, little bits of rock called sand, silt, or gravel, decomposing organic matter, as well as living stuff, fungus, bacteria, vertebrates. Even prairie dogs are considered a soil organism because they help turn over the soil. About half of the mass of healthy soil is living. If you look at this picture, one sign that the soil is really healthy is because it's really dark. If it's really dark, that means it's getting good oxygen, and that decomposition generates black carbon materials. There's a lot of ways of measuring soil, which we can't do because you're not in class right now. So if you have access to someone's yard, you can notice some of these properties just by how the plants are growing. We measure it by NPK, which is the nutrients, porosity, which is how much space is in the soil. Permeability is how well air and water travel through the soil. Organic content is decomposing plant and animal matter. The other minerals that plants need for growth are listed below. One of my professors in college liked to give us this test all the time to see if we could recall everything that plants needed to grow. Here's the trick. Rather than trying to remember carbon, hydrogen, oxygen, phosphorus, potassium, iodine, nitrogen, sulfur, calcium, iron, magnesium, just remember Chopkin's Cafe is mighty good. And we'll talk a little bit about Chopkin's Cafe is mighty good when we talk about the tomato in a little bit. Porosity is the empty space in soil. Soil looks like a fieldstone wall, and I'll show you a picture of that in a little bit. The gaps between the little rocks are interstitial spaces. They're the empty spaces in soil. Permeability is how well connected they are. Porosity is the volume. This is really important because not only do plants need water, and they can't get water if there's no interstitial spaces, but they also need to breathe. Plant roots need oxygen for mitosis and cellular respiration. With particle sizes, we have three types of particle sizes: sand, silt, and clay. Sand is gritty stuff that you can feel if you run soil through your fingers. Silt kind of feels like cornstarch if you rub cornstarch. Clay just does, when it's completely dried out, makes hard clumps. Sand is the biggest, silt is the medium, clay is tiny. And porosity and permeability coincide with size. The bigger the particle, the more pore size it has. If you think about it, If you stack a bunch of basketballs together, there's going to be pretty big gaps compared to if you stack a bunch of marbles together, which would be clay, they'd be really tiny gaps. To give particles size and perspective, if sand were a basketball, silt would be a baseball, and clay would be a BB. Now, you're all thinking that silt's the best soil. The best soil is a mixture of all three that we call loam, because this is a soil pyramid. If you're an AP environmental science, I've already shown you how to use this. But the key is the best soil to have is loam. Until about the 1980s, we often thought if you had clay soils, like my house here in Fort Collins, if you had clay soils, you should add sand. If you add sand, you make adobe, it makes terrible soil. No matter what soil you have, you shouldn't add that sand to it. You should be adding organic matter if you want to improve it. This is more important for determining what kinds of trees and crops grow in there, but this is not something you can easily change. A soil profile is the names for all the layers. If you dig a hole down, you will see soil has different colors. And we're going to talk about all of these in a little bit more detail. The O horizon, which if we go back there, is like in a garden, this would be like your mulch layer. This is like decomposing plants and leaves. It's not true soil, it's all organic material. The next layer down is the A horizon. The layer below that is the B horizon. The layer below that is the C horizon. This is the layer that we need to support humans. The A horizon, it's the most important one. It's like frosting on the cake. A is called topsoil, B is subsoil, and C is parent material. So when someone like builds a house, like when we built our house a few years ago because the old one collapsed, no one was hurt. When we built it, we had to fix the soil afterwards because if you imagine soil's like a cake, you want that frosting. When they built in the house, they did a lot of excavating on the property, and at the end, it would be like taking the cake, mashing it all up, and diluting the topsoil or the frosting with the rest of the cake. It's all the same ingredients, but they're no longer where they're supposed to be. So to fix our soil, we've spent about 4 years building up the soil by adding mulch, compost, as well as some plants to further improve the soil, as well as hauling in some topsoil initially. And topsoil is really important because without topsoil, we can't grow food. And this is a little diagram showing major biomes of the earth. This is where I grew up in the boreal forest. And if you look very carefully, you'll see that there is no A horizon. There's actually about an inch or two, and we'll talk about my hometown in a little bit. Deciduous forest, which is closer to what we have here in Fort Collins, the topsoil is about 6 inches to several feet thick. This is good enough for agriculture. One of our challenges is we don't have much water. This is the best soil on the planet. This is a tall grass prairie where the topsoil can go down 10 to 20 feet. This would be places like Iowa and Nebraska. Tropical rainforests have the worst soil on the planet. They have no topsoil. This is why slash and burn is often not sustainable when we're doing it for things like palm oil plantations. Deserts are kind of a weird one. There's so much evaporation, the soil tends to build up salt crystals. And if you've ever walked through the desert, you know the ground is really hard to walk on. It's basically concrete. The things that form soils, you can see in my homeland in northern Wisconsin. One of the things you need is time. Obviously, the more time you get, the better soil you get. You also need climate. The colder you are, the slower it takes soil to form. You need parent material, the sand, silt, and clay. There's also things with topography, meaning the hillside. So right here, we'd be in Fort Collins at the bottom of the Rockies. We're getting benefits from all the eroded parent material coming in from the mountains. So that's how there's topography. If you've been on the hillsides, though, especially up in the parks, you'll see that there's not much topsoil. There's rocks sticking out of the ground because of the topography. All the soil is washing away. You also need organisms. Now, the world average is it's about 500 years to make an inch of topsoil, but that's an average. In my homeland of far northern Wisconsin, in St. Germain, this area was known for its beautiful white pine forest. They've actually regrown, and it's pretty cool to see. They're about 200 feet tall. About 115 years ago, a bunch of guys decided to clear cut the entire county. And then they created the town of Farmington, Wisconsin. It only had 1.5 inches of topsoil. Its growing season was also only 72 days long. We now know you need about 6 inches of topsoil to grow food. So by topsoil alone, this area was not good for soil formation. Cool thing to know is the reason why there's only 1.5 inches of topsoil up there is the glaciers 15,000 years ago scraped off all the topsoil and gave it to the southern part of the Midwest. So over 15,000 years of soil forming factors, this region's only generated 1.5 inches of topsoil. The reason why is it only has about 72 days of growing season every year. After all the farms failed because there was no topsoil, they renamed the town Saint Germain after a Native American that no one's quite sure if he existed or not. And there's a racist statue welcoming you to Saint Germain of the Native American that probably didn't exist. Up in that area, though, you can see how shallow the soil is and it affects tree growth. Yes, those trees are adapted to those soil conditions. The weird thing is in this one windstorm, you can see the ground literally peeled right up. The tree roots in this region only grow about a foot down. Roots generally don't grow where there's not good soil. In tropical rainforests, the roots are really just spreading right across the surface. So here's a picture of soil horizons. This white layer you usually don't see. It's called the E horizon for alluviation. I won't tell you about that, but because you usually don't see it. But just when people do see it, they think this is ash from a forest fire or a volcanic eruption or asteroid. What this is this water going through this soil became acidic and removed nutrients and organic material from this layer. But I want to ask about this on a test. There's that diagram again. We got two major soil problems. One is erosion. Erosion is soil going away. Desertification is not necessarily turning into a desert. Desertification is soil losing nutrients. The nutrients that plants need, modern agriculture just uses NPK, nitrogen, phosphorus, potassium. What plants really need are Chopkins Cafe is mighty good. And you can see this in the difference between a garden tomato and a store-bought tomato. You can usually get kids to eat a garden tomato, but a store-bought tomato tastes like a watery crouton of sadness. And that's because NPK can make a tomato look like a tomato, but it doesn't taste like a tomato. To make the tomato taste better, you need to increase this weird chemical that tomatoes have called lycopene. It makes them taste like a tomato, and it's also an antioxidant that decreases your risk of cancer as well as decreases your risk of getting a sunburn. To get lycopene in a tomato, you need calcium and magnesium, as well as a little bit of sulfur. Those are not offered by the NPK modern tomatoes. This is why I don't like hydroponic tomatoes as well. The trade-off is the tomatoes grown in real soil are more expensive. The other thing is when we grow things with just NPK, they often not only do they not taste as good, but to make them taste better, we add sugar to them to make them taste better, which then causes other metabolic problems. Which is why I've been showing you how to grow your own food. Now, my sister asked me to explain this. She's like, how do you improve your soil? Ignore the soil pyramid, even though that you see that in textbooks. I think they just like the pyramid. The only thing you need to add to your soil is some sort of compost. No matter what you're doing to your soil, it can always use more organic matter. So if you know anyone who raises chickens, chicken poop really works well in the garden in moderation. And yes, it does smell kind of bad. But otherwise, compost of any sort. You can get compost delivered often from city programs. You can make your own compost heap, decompose your old leaves. Those are what really improves your soil. If you're doing vegetable beds, one other trick is do multiple beds and rotate your plants every year. Don't grow tomatoes on the same spot for 5 years. You want to give your soil a break from whatever plant you're growing, if it's a food you're going to eat, and give it some time to recover. Now, in our yard in Fort Collins, we had incredibly terrible soil. It was so compacted the first year, water wouldn't drain through. A neighbor tried to water one of our trees while we were gone, and it was so muddy and grotesque that it almost ate her. It didn't actually eat her, but she ended up crawling through the yard in a rainstorm because it was sucking her feet into the ground. We had no drainage, and we couldn't even put plants in. Kelly's a 6'1" firefighter that digs fire lines. Even using a pickaxe, we couldn't dig holes to plant any of the trees easily. And the first things we put in didn't do well. The reason why is we had heavily compacted soil. And compaction is when the soil gets crushed down and roots can't grow through it. Our soil had been compacted by the construction of our house and all the heavy equipment. It had been further compacted by years of people neglecting the yard. Here you can see healthy soil, and do you see those little gaps? Those are the interstitial spaces. This is what happens when you drive across a yard, or when a lot of people walk across the yard, or when an excavator is parked in your backyard and hauling away your entire old collapsed house. And the thing is, if you can't dig through it, roots can't grow through it. This is why you'll be seeing a video next week of how to fix the soil and turn over the soil for things like carrots, which need good root growth space. So the ways you fix this are not easy. Where I grew up in northern Wisconsin, this was easy to fix. But here's a cool experiment done at university. This is fluffy soil. This is the same crop of grass grown in compacted soil. They've been grown for the same amount of time. And you can see a major difference in growth. So where I grew up, you can fix it with a deep freeze. Here, the ground doesn't freeze as deep. You can also till or turn over the soil, which we did try tilling, and the soil was so compacted, we broke the tiller, which was kind of a problem. The other way you can fix it is using botany. When we gave up on tilling, we put in prairie plants. The reason why is these things all make shallow roots going down just a few feet. These plants over here are prairie plants. We have things like black-eyed Susans and purple coneflower. Their roots go down 7 to 8 feet. In the course of 4 years, the water is now draining through our soil fine. And even though we couldn't break apart the soil with even 2 large guys and pickaxes, these plants broke it up for us in 3 years. We now have really good soil, and it was all done just by putting in prairie plants like black-eyed Susans and purple coneflowers. So we'll skip that slide and that slide. So we will skip most of that. That is your crash course in soil. Thank you so much.